Hi everyone, my name is Tarun Awala, and this is my Lab 1 charge tapes. So the goal of this lab was to study how charged pieces of tape interact with one another and to calculate the amount of excess electric charge present on each tape. So the materials used were clear tape, ruler, a flat surface, and supporting objects. A Gloucester computational model was also used to simulate the charged tape and the forces acting between them. In the results, the electric charge in each piece of tape was calculated, and the total number of electrons transferred by each tape was also determined. There were three fundamental ideas used during this lab. One of them was Newton's second law, which a system's momentum changes in direct response to the total force acting on it, and its equation was F net equals the change in momentum over the change in time. And the second was gravitational force, which describes the force of attraction that exists between any two objects of mass, and its equation is negative big G times mass 1 times mass 2 over the distance squared. And the third idea was Coulomb's law, which explains how electric charges either attract or repel one another. And its equation was K times charge 1 times charge 2 over the distance squared. On the left, we have the initial setup for the lab, and some of the initial conditions were the mass of the tape, which was 2.02 times 10 to the negative 4 kilograms. The length was 0.22 meters. The width was 0.02 meters. The area was 0.0044 meters squared, and the area occupied by the atom was 1 times 10 to the negative 20 meters squared, and the number of atoms, total atoms, were 4.4 times 10 to the 17. So in this model, it depicts which one was tape A and B, the bottom was tape B, and the upper was tape A, and the system was considered to be tape B, and the surroundings were everything else including tape A, and the distance between both the tapes initially was 0.03 meters. So how was the excess electron calculated? Excess electrons on tape B calculated. So first, I determined the gravitational force on tape B, which was just mass times gravitational acceleration, which gave me 1.982 times 10 to the negative 3 newtons. And then the electric force between both tapes is given by Fe equal to Fg, because both of them just cancel out. And essentially, the electric force is also equal to 1.982 times 10 to the negative 3. And the electric charge on tape B could be figured out using Coulomb's law. And the charge derived using that was 1.184 times 10 to the negative 8 coulombs. And the total number of electrons lost was determined by dividing the total charge of the tape by the charge of a single electron, and that gave me 7.4 times 10 to the 10 electrons lost. So computational model was also developed to better analyze how ideal scenario would have been. And in the beginning, we just have some basic constraints such as constants and also the initial conditions that we talked about earlier. And then I worked towards calculating the electric and gravitational forces on the objects in the experiment, and also the electric field and the charge at the end. And on the right, we can see a free body diagram and also the charge on the tape, the number of electrons lost from one tape, and the atoms per electron lost, and electric field and electric force. And these are the ideal results, obviously, due to experimental error that we cannot avoid in the real world. Our results were just slightly different. So these are because of the assumptions we made, which were that the air resistance and friction are small enough to be ignored, and the long strip of tape is treated as if all its charge is concentrated at a single point, and each piece of tape is assumed to carry the same total charge spread uniformly across its surface. And we know these assumptions do not hold true very well during the experiment. So the errors. The charge may not have been evenly distributed along each tape. Some of the charge may have been lost due to handling or interactions with the surrounding environment during experimentation. So let's talk about some discussion questions now. So the first one is, why is it important to handle the tape as little as possible? So when the tape comes into contact with hands or any other objects, it begins to lose its charge as electrons transfer back, causing the tape to gradually become neutral. And number two, what if electrons and protons had inverse charges? The results observed in the lab would not change at all, even though the tape would now carry a negative charge instead, the tape would still repel one another and continue to be pushing the other tape away. Thank you for listening.